Welcome to GraphQL-io. With it, you can do real-time applications with the help of GraphQL. Well, as the subtitle says, in the past we had RPC, remote procedure call, then SOAP, and today everybody is using REST for the interfaces between front-end and back-end. But it can be made better with GraphQL. Or, even more specific, with GraphQL-io. Let's start with the first part. What about REST? Well, models are not right or wrong. They are more or less useful, as Martin Fowler once said. But you can actually replace models with technologies. Technologies like REST are not right or wrong. They are more or less useful. Let's have a first look at REST on a coding perspective. Let's have an example here. We take the HAPI service and start on localhost 12345 port, a REST service where /API/hello with get can be requested, and it returns an hello world. There's also a post variant of this endpoint where you can use an application JSON payload, and here a parameter name can be also specified in the payload instead of the URL. And it also returns hello world or this parameter. Then we look at this in the browser and we see, yes, hello world is returned. If we pass in our name parameter, we get foo back. Well, that's fine. On the command line, we can do the same with curl. We can easily request our /API/hello endpoint and feel happy because hello world is returned. And also we can pass in our parameter name with a value of foo, and voila, hello foo is returned. The same can be done with a post request where the name parameter is coming in through an application JSON based payload. You see the same name foo is passed in and hello foo is returned. REST is also very simple when it comes to coding server and client. The server we have already seen. We have such a server here once again with HAPI. It listens again on localhost and provides this post endpoint for /API/hello. And here we have a REST client. It is as simple as a server. We post to this URL, provide a JSON body, a payload, and in this payload we provide our parameter name, and its value is coming here from the command line. Let's try this out on the command line. If we start this version of the code, we see first an hello world, and if we pass in now our parameter value foo, we see hello foo. Well, that's just fine. It works as intended, and that's the reason why REST actually is liked by a lot of people, because it feels very, very simple, very lightweight. You don't have to do much overhead, and you can easily use it within the code, or on a pragmatic level. You can use it on the command line with curl. Everything feels very happy about this. But there are pain points with REST, especially when it comes to this hell of endpoints or this inflation and a lot of unsuitable features we nowadays not actually need. The first point is if you have n entities, n domain-specific entities, and there's usual 4 CRUD operations for create, read, update, delete, you immediately get a myriad of endpoints, especially you to this n times 4 endpoints for aggregations, projections, or domain-specific operations are added. So for a typical business information system where you have about 50 or 100 entities, it easily becomes about 400 or 500 REST endpoints. And this is already horrible by itself. The next point is the features of REST. We have client-server communication. Well, this is a fine point. The statelessness, you usually don't need very much in practice when it comes to front-end to back-end communication, because it's very, very stateful today. Caching, where REST would be very well playing here with proxies, is also a 0 point, because nowadays front-end and back-end communicate with an end-to-end encryption via HTTPS, and there is no more caching at all. The addressability of resources, yes, it's a nice feature. The distinct representations, on the other hand, is again a 0 point nowadays, because whatever you do with REST, sure, it is representational state transfer, and yes, you can transfer JSON, XML, or whatever over it, but usually your front-end and back-end nowadays just talks about JSON and nothing more. Self-documentation, yes, this is a nice feature, but hypermedia as the engine of application state, hey to us, this is another feature you don't need today when it comes to front-end to back-end communication, because your front-end is very, very tightly tied to the backend. All dialogues have a structure directly tied to the data model of the backend. There is no need that your frontend goes to the backend and says, okay, just tell me, what can I do with you? Let me do an explorative crawling through all those data and endpoints here. So HTOS is never done in practice when it comes to front and back end communication. That's the reason why nobody of you actually are doing REST in practice. It's, yeah, REST-like, REST style, RESTful, whatever. But this feature you never need. Code on demand, another nice feature where each endpoint gives out code which is then executed on the command line or on the inside the browser. But this is also not used today. Sure, there is a piece of code, a very large piece of code which is pushed out in this way, but this is just your HTML5 single page app, which is once arrived on the browser, and then the whole REST communication usually does no code on demand. It really just transfers JSON, pure data via JSON over HTTP. And yeah, okay, the layered architecture is a fine aspect, sure. So you see, from those 9 essential features of REST, already 5 are more or less 0 points today. Just 4 remain, and this is another reason why REST is not really suitable for front-end to back-end communication, in my perspective. Another great major pain point of REST is the fact that you have usually different front ends today. It can be the same UI or the same code, but running on different devices means it has to react different and perform different data access patterns. If you take a desktop, a classical desktop, which has requested the data from the backend and provides it in a classical master detail view, means you need first request from the backend the information for the master view, and then once you click on one of the items in the master view, the detail view is requesting its information from the backend. And because we are on a desktop, more or less all details are fetched at once. If you take now the same application, exactly the same application and the same data from on a phone, it looks completely different, because here the master detail is actually split into a master and a detail and a sub-detail dialog, which means once you click on an item on the master, a detail dialog loads half of the detail information, and once you swipe or do another gesture, whatever, the remaining details are loaded. So even the same application, the same backend data and the same UI has different access patterns or different demands for different access patterns when it comes to different devices. Something REST doesn't play very well with, but once you have a solution like GraphQL, as we see later, where you have a query language available, this becomes possible. The next point is about backend and front-end team synchronization efforts. This is horrible in practice. You usually ask yourself, how many more REST calls do I have to make to get my data? Why cannot I just access one-to-one the server's data model directly? And what? Just another REST endpoint to provide a few hundred endpoints per application. Is this really true? Yes, it is true in the REST world. So, GraphQL to the rescue. Because nothing, not all the armies in the world can stop an ID whose time has come. And that's especially the case, in my opinion, for GraphQL. Here, the first point from my perspective is that GraphQL really provides a very clear client and server responsibility split. The server on one side provides entities and the relations And this way the server says, okay, I say what to provide those entities and what to connect the relationships and who is authorized by the session to access those entities and relationships. Nothing more. Just what to provide, what to connect, and who to authorize. The client, on the other hand, does exactly a different thing here. The client decides where to start with all those entities, where to continue crawling or going from relationship over relationship and from entity to entity, and what to fetch in each step, those attributes or fields of the data entities. This split is not really possible with REST, because what REST actually does is it shifts more to the server. The server actually, with these endpoints and other things, clearly says what is possible. The client is not really able to do a so-called client-directed query. Yes, you have different endpoints, and though the start is possible, but especially those points where to continue and what to fetch is not such easily possible with REST. So how does this actually work from a principle perspective in practice? How does GraphQL work? Well, you have in the middle a GraphQL engine at the core of the whole play, of the whole game. Then we have a GraphQL schema where in a contract first approach we define what our data model looks like on the server. Here in this example, we just define a query schema which starts at a root type, and there is one type below under the identifier hello, and this hello returns a string. Then we have to provide resolvers, which tells the GraphQL engine how to resolve queries for this root type and for this hello below the root type. Here in this example, it is just a closure in JavaScript which maps hello directly to the literal world. And then we have a GraphQL query coming in. Here on the left, we see a GraphQL query for this hello field and a corresponding JSON result, which then returns hello and the value as requested world. When it comes to the client-server communication, because GraphQL actually does nothing, that doesn't know anything about I/O, and especially not about HTTP, WebSocket or anything, but once you place this stuff on the server side, and then the game should be clear, the client is the part which does a request for this GraphQL query, then the engine and everything we already talked about is actually happening, and this JSON result which is coming out provides the response which goes back to the client. So this is actually how GraphQL works in a client-server fashion. And this is what usually we are talking about when we say it is client-directed query, because the client is able to craft up a query, pass this in a request to the server with the GraphQL engine executes this query, and the JSON response is coming back. An especially interesting point is when it comes to authorization, where to do authorization when it comes between GraphQL versus REST. Well, on REST, you do the authorization on a per endpoint basis. As we will see in the following, in GraphQL, we don't have multiple endpoints. It's just a single endpoint. And this single endpoint, later named GraphQL or Graph, cannot do the authorization at once. Instead, we move the authorization in the server down to the resolver, there where the actual data is requested or accessed. And this is an interesting point because this allows the client, through his client-directed query approach, to actually start at arbitrary positions with arbitrary entities, follow arbitrary relationships, but whenever the server actually assembles a piece of data, it checks whether it is allowed by the current session of the client, independent where it was started or continued the client. But if a piece of data is involved in a query result, it is checked whether the client gets this information. If it is not allowed to request this information, a null is automatically replaced by the GraphQL engine into the JSON result. Now let's look on the code level. First, without any networking or HTTP or other I/O, just directly on the command line and in memory to get an impression what this GraphQL engine is actually able to perform. So the first thing is we are using Node.js and have two NPM modules, GraphQL and GraphQL tools. GraphQL tools allows us to create an executable schema here. The schema is actually those two lines as already shown before. It defines a root type for queries and this root type has an entry hello and this maps onto a string and a corresponding resolver which says okay, under this root there's an hello and it maps to this literal world. That's all to define the schema, and then we execute the GraphQL engine by passing in this schema and this query for the hello. This is actually a multi-line literal once again in JavaScript where this entire GraphQL query is there, and we get a result back and just dump out this result on the console. So if we execute this, we see yes, there is hello world as expected, but it can do more. The first thing is GraphQL is able to get arbitrary or process arbitrary parameters directly on each field. So this hello field, we place a parameter name which is a string. Then the resolver gets a parent and an args argument, and through this args argument we can access this parameter name here. For the query, we just add in parentheses here this name and we pass in foo, in the hope that we get a hello foo. And exactly this is happening here, but it is not obviously still hard-coded directly in the query. So the next step is to make it not hard-coded. We are now actually making a parameter for this for the query itself. This is through dollar. Here, all dollar variables are actually variables coming into the query from externally. We pass this to the hello, and externally we pass it in through a variables hash here, where the name of the name, the value of the name parameter comes from the command line. It is then passed into the query, passed into the hello, comes in through the args, and here it is taken out and creates our result. If we try it out on the command line, we first see that hello world is once again provided, and if you now put in bar, yeah, hello bar comes out. Fine. The next point is, let's see how to wrap this GraphQL engine now into a network service with the help of Hapi. Once again, Hapi is a REST framework as we've seen before. We create once again this Hapi server, the exactly same schema and resolvers as before, but now we create a Hapi route for a post endpoint through /API. This endpoint accepts a payload in application JSON, takes out of this application JSON payload a query variables and operations fields, and places these things onto a call to the GraphQL engine again. And the result of this GraphQL engine is then wrapped into a regular REST response. Then we have a corresponding client here, a simple HTTP client, which posts onto the URL provided above by the server, and we provide a JSON payload. In this payload, we provide exactly those query and variables the server expects. This is exactly as before. The query contains the GraphQL query, the variables, the parameters for the query. So if we start this once again, we see our hello world once again, but now it is completely a client-server communication. Even if we pass books, yes, we get it back. The interesting point now is that this GraphQL engine does a lot more. It especially has very nice error handling built in. Just replace this hello with a German hallo, and let's see what happens, because it's a typo. If we execute this example, we see immediately that the GraphQL engine understands that this field hallo in German does not exist on the root type because it is actually spelled hello. Interesting is also it provides us the line and column numbers where in the query this problem occurs. But this does not just work for typos in the query. It can be also exceptions thrown by arbitrary resolvers. So let's just throw oops here in our hello resolver. If we execute this on the command line, we see a very nice error message where exactly our oops comes out, where the location once again comes, and now there's also a path information because the engine tells us that inside the recursive execution under hello this problem occurs and the data is now null because an error occurs. And you see around the messages in errors there's an array because the GraphQL engine actually aggregates up all error messages and provides us all information beside the possible data response. If you do this in practice, it becomes more involved, obviously. So the GraphQL engine is in the middle of our server-side software stack. There is a network connectivity through Node and HTTP. There's this REST with HAPI. There is the GraphQL engine, a little bit of glue code, usually in practice. And then it goes in your resolvers towards the object relational mapper like SQLize directly to the relational database, for instance, like PostgreSQL. So this is an illustration how this whole backend software stack looks like, and on the right side with particular tools and frameworks. So it's a little bit involved, as you see, and what you usually want is to simplify all this. The problem is GraphQL is very generic and it does not actually know anything about networking and all this stuff, so it becomes a little bit complex here. So we want to make it as lightweight and as simple as REST again, and for this graphql-io comes to the rescue. It allows everything should be made as simple as possible, but not simpler. And this is exactly what happens here. Graphql-io is a pre-integration of a lot of frameworks and libraries on both the client and server side. It especially provides the possibility that GraphQL can be driven now over HTTP or WebSockets. WebSockets, especially WebSockets, because we want server push, as we see in the following. For this WebSocket, we want real-time query subscriptions, and for this data access scope tracking, we want incremental GraphQL schema definitions. We want authentication through a session, authorization in the resolvers, a little bit of a GraphQL or graphql API UI for explorative back-end crawling, and especially also blob delivery for things like pushing out the static JavaScript code of your HTML5 single-page app. All this stuff is provided by GraphQL-io on top of a REST service like HAPI and the GraphQL engine. From an architecture point of view, here as a functional view shown, you get two APIs, and GraphQL-io client API, shown here red on the left top, and then GraphQL-io server API shown in red on the right at the top. And below these two APIs, there's a lot of pre-integration of existing libraries and frameworks, as I said, because this is actually what GraphQL-io is. It's a pre-integration of a lot of solutions and provides a very simple, very lightweight API again. So just let's have a look how this actually looks like when we are using GraphQL over HTTP or WebSocket between two microservices, for instance, directly on the code level. So the first thing is we are using two NPM modules named GraphQL-io server and GraphQL-io client. We have a server and a client in a few lines of code. The server says, okay, on localhost we are providing once again our server, and we instruct the server that we have a GraphQL resolver here. This resolver is actually a combination of a resolver function and this hello name string, which is actually a GraphQL schema definition for this resolver. So we have something like a signature and the corresponding JavaScript function which maps again onto our world. Then we start the server and stop it again, and in the middle we have a GraphQL-io client. As simple as the server, we are connecting to the exact same URL the server listens on. We are connecting to this, later disconnect to this, and then we do a GraphQL-io query, which is actually nothing more than a GraphQL query. We have our GraphQL query from before here, and a variable binding to get the possibility to map external values onto our name parameter here. The result is once again printed, so we actually see it on the command line. If we start this once again, we see that we get hello world back. So now GraphQL over HTTP or WebSocket works as lightweight and as simple as REST before. The next point is we want to actually also use Graphql-io not just between two microservices and this way on the Node.js part, but between a Node.js backend and a HTML5 single page app front end. So now let's see how this actually looks like if we are using this in this context. Well, we once again have a GraphQL-io server. We start this server. This time we tell it to actually provide a front end, which is just an HTML file on the current directory, and a blob, which is a request for our GraphQL-io client library. A little bit of debug information is enabled, and this debug information is then put out to the console. And once again, we instruct GraphQL to provide a resolver for our hello field. This is exactly the same code as shown before. Now we have an additional, after starting this server, we are also now providing this one client.html file, which requests from the server this blob for the GraphQL-io client library, instructs this GraphQL client library to connect to the server and perform two queries, one for hello and one for hello with a parameter foo. If you now start this server, it will listen on HTTP and WebSocket. And if we now go to our browser, we can request this page from the server, and you see it shows our hello world and hello foo as expected. On the network side, we see that the browser requested the HTML file, then the GraphQL-io client library, and one endpoint graph. And this is actually an endpoint where WebSocket is spoken. Here we see 4 frames, 2 for the GraphQL requests and 2 for the corresponding responses. Now let's look on a more realistic example here instead of a hello world. We have an UML class diagram on the left here. This is just a data model consisting of 2 entities. That's the reason why the example application is named U and P for units and persons, because it has a data model just of those 2 entities, a unit and person, and a few relationships. Units have parent units, person can have a supervisor, there is a unit has 1 or 0 or more members as persons, and the person belongs to 0 or 1 unit, and a unit can have a special person under this role director. This UML class diagram on the left has a direct corresponding GraphQL schema definition language. Here on the right, you see it is directly a mapping of the UML class diagram. The only additional information is that a top-level schema is defined for query and mutation. Queries are our read operations, mutations are GraphQL write operations. And the only syntactic sugar you see is that relationships with an arity of 0 or more are actually encoded as an array with those brackets, and the exclamation mark in the schema definition language means not null. The corresponding dialog of this simple example it's an example application which just has this one single dialog, and because it is 2 entities for more or less editing something like an organigram, it has 2 areas. On the top, this units and persons has units and unit in a master and detail fashion to edit the unit entity, and at the bottom there is persons and person in a, once again, master left and detail right, master detail fashion once again for the person entity. Now you cannot just request this, as you see in the URL, this domain-specific front end and this UI, but also a built-in GraphqL named generic UI. And with this generic UI, you can do now a little bit of exploration of the backend. We will see this in a screencast in a few minutes, but just have a few screen snapshots here. The first thing is you can do a query for instance, units, and give me the ID and name of these units. You see that JSON responds directly on the right side, what this backend gives us back. We can also be more specific and say, okay, just grab a particular, enter the data model at a particular unit, then fetch the abbreviation name and ID of this unit, then go over the relationship director and fetch their initials, name and role attributes. Once again, go over the relationship members and fetch their initials, name, role once again, and go also to the parent unit and fetch the abbreviation and name of the parent unit. If we execute this more complex query, you get a more complex response. And this is actually what is such great about GraphQL, because it allows you to formulate complex queries and get very nice responses as JSON back again. And you see this structure of the JSON responses directly follows one-to-one the structure, including the names inside the query. But it doesn't stop GraphQL on the on queries. It can also do mutations. This is the name for the write operations, which also can include a few read operations. But whenever you want to update anything, the terminology of GraphQL is you want to mutate things. So we have a mutation here, and in this mutation we do two things. We do a before label here, and in this label we want the particular unit we are requesting through an external parameter ID, and grab out this ID in the name. You see on the right we get before with ID and name, so it is actually an entity of the research and development department. And then we do another label after, request again this unit with this externally provided ID, but perform an update operation, and this update operation updates the name attribute of this unit entity, and we fetch once again after this update immediately the ID and name. And you see, before we have the Research and Development Department, and after this we have the German Forschung und Entwicklung. Now let's look at this on in practice, how it actually looks in a screencast of this particular application. We are reloading this application. On the left, have the debugger on the right. You see a lot of things are requested. And if we now start clicking around in the application, you will see it loads the stuff, but nothing happens in the debugger. Why? Because there's a graph endpoint, and there is the WebSocket communication. You see, once we click around in the application, WebSocket GraphQL frames with requests and responses are going over this connection. It is actually here switching protocols to WebSocket, and that's the reason why you see no more REST communication, but over this established WebSocket or remaining communication with GraphQL-io. We can also go to /API. This is the built-in GraphqL UI, or a generic UI, where you can explorative testing out things. You see, we can take the query from before, get a response. We have also a document explorer. If you know Swagger or something like this for REST, it becomes familiar to you. You can have the possibility to, with hyperlinking here or hypertext, explore the API. And once you read it on the right, you can immediately test it out on the left and see the results in the middle. Very, very nice. And this is already out of the box provided by GraphQL-io. You can also have auto-completion with control space. You see an ID is here entered, and it is immediately shown. We can also do our mutation from before to just showcase you this more complex example of an update of the backend. If we execute this, we see exactly what we have shown before. Our research and development is changed to the German Forschung und Entwicklung. So this is very nice and provided out of the box by GraphQL-io. In the code of the domain-specific front end, those queries which we in an explorative fashion assemble together can be directly put into multi-line string literals here in JavaScript. and the external variables are going into an hash here. And this is the way you are actually driving GraphQL-io from your domain-specific front-end. And now, this is not just which GraphQL-io provides, it's one more feature exists here. GraphQL-io query subscriptions. And this is the killer feature of GraphQL-io actually, because it provides you to be able to perform queries and whatever the query is, to subscribe onto updates of the result for this query. And the point is, yeah, you've got to start with the custom experience and work backwards to the technology, as Steve Jobs already said. The point is, in a lot of applications, you want real-time updates. You want to be those UIs to be reactive today. And the key for this is data access scope tracking inside GraphQL-io and the real-time query updates which follow these scope tracking. So to get an illustration how this actually works, the server in the middle has a graph of whatever it is. It is a few entities, A, B, C, D, E, F, and there's a client 1 on the left, here in brown, which does a query for A, B, and C. Okay, fine. Nothing happens except that this client requests this query, gets a response, shows it in its UI. Then another client comes. Here on the right side, client 2, which does a mutation. It starts differently by, instead of A, at D, but it goes also to B and performs an update on B. It does also an update on E, but it doesn't matter very much. The point here is that client 2 touches the entity B, which with an update, and this entity is part of the result of a query of client 1. And the effect is, once this mutation happens by client 2, the query of client 1 is automatically refetched. And this way, the client 1 automatically gets an updated response. How does this actually look like in code? Well, first in a very simple example directly on the command line to get an impression here, we are coding a server and 2 clients with GraphQL-io client and server. Once again, we have a server here on the top, and we have 2 clients, a client 1 and a client 2, all made with GraphQL-io. The server on the top does nothing more than have, once again, listens on localhost and has a single entity, which is named counter. So it has a lowercase counter, which maps onto a type uppercase counter, and this counter has a value and an increase field. Through value, we can get the current value. Through the increase, we can increase the counter. And a corresponding object in the memory. Then we have a resolver for those 2 things. One resolver is to actually get to the counter entity, which does nothing more than just returns the counter inside the memory. And then for counter, once you access increase, you get you need a resolver which adds 1 to the value and returns this counter. All other resolvers for value in particular are not required because GraphQL substitutes them automatically. And then we have those scope record calls, and this is everything which is needed to instruct GraphQL-io that below at the top it is read the counter and the value is changed in the increase field. Then we have a client which connects to our backend and queries the counter value. Nothing more, it just queries this. But instead of the usual .then method, we have a .subscribe method, which means we get here asynchronously the result, but we get it all the time as long as we are subscribed. And we have a client 2, which also connects to exactly the same backend, but once per second updates this counter through counter increase and also shows then the current value after the increase. So very simple, a counter which is observed by client 1 and this counter is increased by client 2. Both print the current results of their GraphQL query. If you now perform this execute this on the command line, we see client 1 has a value of 0, 1, 2, 3, 4, 5, etc. And it is all once per second, client 2 updates the counter and client 1 immediately reacts on this, reperforms the query and shows you the updated counter value. So it is always a pair. Client 2 does the mutation, client 1 does the corresponding query. And this for all those numbers 1 to 12 here. Now let's look how this actually looks like in a real application. First, just an example application, once again in our units and persons application. We start this application in two browsers. On the left, we see it in Chrome, right on Firefox, completely different, one even in English and one in German. We update our name field, we see it is directly reflected on the right. We update abbreviation on the left and it's directly reflected on the right. We update, for instance, the parent unit. It's directly updated on the right. We can also switch now to the right side, update a field independent, whether it's an input field or whatever. Once we update the stuff, it is cleared on the left side. Once we update, share it back here, it's updated and reflected on the left side. We can remove an entry, it is updated and reflected on the left side. We can add an entry and it's once again reflected on the left side. We can also go to the left and in the master detail clear a few things. You see it is directly cleared on the right side once again. We can also add entries. It is also added on the right side. We can just open those entries, enter a name, and it's once again this crux reflected on the right side. You see our crux is reflected on the master and the detail, master and detail on both sides. So this is a completely different user experience we have in HTML5 single page apps. It actually means those apps are in real time communicating with each other through the backend and immediately reflect changes, which means, for instance, from a customer perspective point of view and a customer experience point of view, that dialogues have a lot less locking and blocking situations because queries are, data is updated in real time and queried in real time. We can also look at another example. Now, a real production app named Vote. This is a simple mobile application which can be used in an event by 50 or 100 people to give their feedbacks. And once a feedback is entered, it is shown what the current group feedback in total is. Even if others are still updating, it is already reflected. Just let's look how this actually looks like. Person number 1 updates this, sees the result. Person number 2 gives its vote and 1 and 2 sees it. 3 gives its vote and also 1 and 2 sees the updates, and person number 4 gives its vote and person 1, 3 and 2 and 3 also directly reflect this information. Sure, this is just an optical gimmick here, that the bars are reflecting the current status, but this is actually what shows you what is possible with Graphql-io, and especially you have to do more or less nothing in this app to get this, because all you have to do is to perform those scope trackings and say, okay, when do I read something, when do I write something? Everything else, the update of the clients, the refetching of queries is all done by Graphql-io automatically. Yeah. Finally, to sum it up, the limits of your language are the limit of your world, and the same instead of language is also your technologies. When it comes to remote network interfaces, there's a lot of technology available. You have the remote procedure call from the 90s. You have SOAP from the millennium. Then we have REST, which is more or less, all dancing, all singing all the time. And now we have also GraphQL, and especially the variant GraphQl-io. The point, if we just compare this here, the base concept for RPC and SOAP was more or less, a remote procedure, a remote function call. So the function was the base concept. REST changed this onto resources, and GraphQL is also more or less on the resources level. The resource is just a graph of arbitrary things. In our example, it is the nodes where the domain-specific entities and the edges in the graph were the relationships between the entities. Then we have also a uniform access principle in REST and GraphQL, which means that all REST endpoints or GraphQL fields can be just plain data, but can be also replaced by getter and setter, and this way code executed even if the entire interface does not actually change. The network transport and payload encoding was on the RPC level, proprietary encoding over TCP. SOAP was this horrible XML over HTTP communication. REST started with XML and later, usually in practice, changed for JSON over HTTP. GraphQL is not really tied to HTTP, but when it is done, it is usually also JSON over HTTP. And Graphql-io provides JSON, CBOR, and actually message pack and other things over HTTP and especially web sockets. And this way provides also a bidirectional communication. The application interface in the 90s where method stubs were created, which was because the interface approach was a contract first approach. REST is more or less a code first approach, where you have an API at hand. Yes, you can with WADL, you can actually do contract first, but more or less REST is most of the time a code first approach through an API. GraphQL provides an API, but actually a domain-specific language for schema definition and query. And this way, it is actually a contract-first approach again. And because Graphql-io bundles these contracts together with the code in a very nifty way, it is a combination, I would say, between code first and contract first. But the main point is that with REST and GraphQL, or between REST and GraphQL, is that the client-directed queries becomes possible because you have this DSL, this query language available on the client side. You also, on the REST level, you have an explorative API. This is very nice during development. You have real-time query updates in Graphql-io, this killer feature I presented before. The low network footprint of RPC and REST is once again possible with Graphql-io because queries are compressed, and there's even with CBOR instead of JSON compressed framing over WebSocket. You can also do this blob transfers, and even the transport sessions as in REST are once again provided by Graphql-io. So, once you do your next front and back end communication, think about GraphQL. Go onto graphql.org to get an impression what GraphQL is about. But remember that you want GraphQL over HTTP or WebSocket, and for this, two projects actually exist. There's this large Apollo project, which actually does GraphQL over REST, and there's Graphql-io, which does everything GraphQL Apollo does, because Apollo is part of Graphql-io, but these additional query subscriptions, which are very, very powerful. So from my perspective, your next front-end and back-end communication should be based on GraphQL-io because it provides what you want, reactive UIs. Thank you for listening.